Welcome back to the session 5 of number system. Here is one more exercise which has been deleted from your portion, that is exercise 1.4. You can skip this exercise because it is deleted. Okay. Next we'll go to the exercise 1.5. In this exercise we'll see the first question in today's session. So in this he is asking you the first question: classify the following numbers as rational or irrational. So you can find there are numbers in roots in all these, okay, and there is even pi here, okay. So let me recall, I said you that all the numbers which are non-perfect squares, all non-perfect square numbers, root 2, root 3, root 5, or root 7, or root 31, whatever it may be, okay, these numbers, do they have a perfect square root? No, they have a square root, but it is not perfect. Like root 4, root 4 is 2, root 9 is 3, root 16 is 4, okay. So these are perfect square numbers. These are perfect square numbers, and these are non-perfect square numbers. So all these non-perfect square numbers are irrational numbers, okay, whereas perfect square numbers are rational. So keep this in your mind that all the non-perfect square numbers are irrational numbers, okay. Another thing you must know here is non-perfect square number with any other number added to any other number gives you irrational number, okay. So all non-perfect square numbers are irrational. So root 2 is 1.414, so on, which never ends. If you add 2 in that, what do you get? You get 2.414, so on, which never ends, okay. That is non-terminating, non-repeating decimals. I said you in the introduction that all non-perfect square numbers, these numbers gives you non-terminating, non-repeating decimals which are irrational. So when this is non-terminating, non-repeating, and if you add 2 in that, the result will also be non-terminating, non-repeating. Or you multiply root 2 by 2, that is also irrational, okay, that is also irrational. Or 2 minus root 2 is also irrational. Or if I say root 2 by 2, that is also irrational. So whenever an irrational number comes with rational, okay, whenever an irrational number comes, that is non-perfect square number comes with a rational number, either in addition or in multiplication or in subtraction or you say in division, however it comes, if the that will give you an irrational number, okay. So all these numbers have a non-perfect square number, so all these numbers are irrational, okay. Keep this in your mind. So following the same concept, we have to do first question of exercise 1.5. so let's begin with it. So 2 minus root 5, which is 2.236, so on. This is non-terminating, non-repeating, and an irrational number, as I said you. So rational minus irrational will again give you irrational number, okay. Whenever an irrational number comes in with a rational number, okay, it will give you an irrational number. Got it, everyone? So 2 minus root 5 is irrational. Here you can see 3 plus root 23 minus root 23 in the second question. So I can cancel this plus root 23 minus root 23. What is the final answer? 3. But 3 is a rational number, okay, because 3 can be written as 3 by 1. Because the result is 3, there is no root in this. This is a rational number, okay. So these are very important concepts for MCQs especially, okay. So listen carefully. I'll give you a quiz, short quiz based on the same concept which you have to answer, okay. Next one, 2 root 7 by 7 root 7. So what can I do here? Can I cancel this root 7 and root 7 in this? Because they are equal and they are in multiplication. So root 7 is cancelled. 2 by 7. 2 by 7 is a rational number because it is in the form of p by q. The next is 1 by root 2. Root 2, value of root 2 is 1.4142, so on, which never ends. So root 2 is irrational number. This root 2 is irrational. So 1 by root 2, that is rational by irrational, is also irrational number, okay. Next, pi. I said you in the introduction that pi is a unique irrational number, okay. So when you find the value of pi, that is 22 by 7, it will be non-terminating, non-repeating decimal, okay. So when I multiply this with, when I multiply 3.1415, so on, which never ends with 2 or whatever, then I get a number which never ends again, isn't it? So finally I can say 2 pi is also an irrational number. So finally the conclusion is rational plus irrational, remember this, is irrational, or irrational minus rational will also give you irrational number, or rational into irrational is also irrational, okay. Or you can say irrational by rational, or rational by irrational. These both are also irrational. So you can check out whenever irrational number comes, okay, in with any rational number, it gives you an irrational number, okay. So complete this in your classworks.